Hello. Today we will discuss about the preparation of data. Now, what is preparation of data? That suppose you are having many data from many stations during many years, and suppose you are trying to use where we can use we can use the data for future prediction, right? But before using those datas, we need to check for something. We need to check the datas with respect to the continuity and consistency, right? Continuity we need to check, and the consistency we need to check. Now, what is continuity? That will lead, if the continuity is not there, that will lead to this one, that is missing rainfall data. Or we can say, if missing rainfall data are there, then we can say there is continuity error, right? Now, what is continuity error or continuity? Where we can say continuity is broken? Suppose you are having one station and you are looking at the previous 30 years of data, and suppose you're seeing that maybe that station is not having any data in a particular year. Suppose in 2020 pandemic year, maybe in this particular year that particular station X is not having any sort of data. So whenever you are trying to find out the previous year's data, this is missing. Well, that can be missing data can be because of many reasons. There can be any sort of damage or fault in rain gauge station for a particular period or something else. For those cases, first of all, we need to find out that missing data. We need to estimate that missing data. Obviously that will not be correct, but we can get the missing data using the normal rainfall. Now, what is normal rainfall? Normal rainfall is basically the average rainfall value at a particular date, maybe in a particular month, or maybe in a particular year. Particular date, maybe suppose 7th August. Particular month, suppose we are trying to find out the annual normal rainfall in August, normal rainfall in 7th August, or in a year. What will be the normal rainfall over the year? So that indicates the average value of rainfall of that particular date or that particular month or year over a specified 30 years. So we will need to have 30 years of data, and if you average it, then you will get the average or normal precipitation. If it is annually, that will be annual rainfall, normal annual rainfall. If it is for a particular month, it will be normal rainfall for that particular month or for that particular date. Thus the term annual rainfall, normal annual precipitation of station A, it means the average annual precipitation at A in a year, in 1 year, based on specified 30 years of data, specific 30 years of data. Now how we can use, how we will use the precipitation, our normal precipitation, to get the missing data. Suppose there are m number of stations in a particular catchment area. 1 2 3 4 number of stations are there, out of which, and as because 4 number of stations are there, so we can find out normal precipitation, normal annual precipitation. Suppose we are finding out the missing data for a year. For 1 year of period, one missing data was there. So for that case we need to use the normal annual precipitation. So suppose the normal annual precipitation for those 4 stations are N1, N2, N3 and N4, out of which one station, suppose station number 3, this is 1 2 3 and 4 and 3 and 4, so out of which 3 number station was faulty for a particular year. So for a particular year, suppose 2020, I have already told you that for a particular year we have got the data from 1 2 and 4, but 3 is missing. So precipitation, annual precipitation for that particular year, P1, P2, P4 and there P3 is missing. So in a particular year, suppose this annual rainfall is missing X station X is not having the data, but obviously as because you are having m number of stations, so m minus 1 number of station will provide you some data, will provide you the annual rainfall, that is P1, P2 up to Pm minus 1. So Px is missing. So how to find out Px? We can find out the Px using 2 formulae. If normal annual precipitation of that station X, in our case 4, no sorry, in our case 3, if the normal annual precipitation of 3 station does not vary more than 10% from N3 does not vary from N1, N2 and N4, it does not vary more than 10%, then we can go for this arithmetic average method. And if the normal precipitation of this station varies greater than 10%, then we have to go for this method, that is normal ratio method. Arithmetic average method is simple, that you have to find out the average. That means suppose we are having 4 stations, third number was missing, you add up for the particular year 2020, P1, P2, P4 are there, so you add up those values and divide with 3, you are finding out the average value. So this will be the value, summation of Pi, where I will vary from 1 to m minus 1 divided by m minus 1, that will be the Px value. But if it varies, the normal precipitation varies 10% greater than 10%, then you have to go for this formula where Px, we are finding out simply nothing but we are finding out a ratio of annual precipitation and normal annual precipitation of each and every stations. So basically this is nothing but Px by Nx is equals to 1 by m minus 1. We are dividing this m minus 1 as because we are taking the summation, summation of P1 N1 plus P2 N2 and so on. So that is why we are, as because we are summing it up, we need to find an average, and to get the average we need to divide with n minus 1. So basically this is the concept from which we are having, we are taking this in this side. So Px is equals to Nx by m minus 1 summation of Pi by Ni, where I will vary from 1 to n minus 1. So in our case, if you consider, in our case 1 2 3 4, in our case P3 for that particular year will be equals to N3 divided by 3. M number stations are there, 4 number stations, 3, 4 minus 1, and multiplied by P1 by N1 plus P2 by N2 plus P4 by N4, and that is it. So we are finding out the ratio, normal ratio, right here also we are finding out the ratio. So that means normally this amount of precipitation occurs for a particular, if this amount of precipitation occurs in other station, what will be the precipitation in our station? Nothing but this concept. Okay, so one example related to this is there, that is, if the precipitation, normal precipitation over 4 areas A, B, C, D is this and this centimeter, normal annual precipitation. If in particular year 1985 A, B, C data is there, but D is having missing data, D is missing the data, and for this year the annual precipitation in A is this, B is this, and in C is this in centimeter. Then find out the missing data of D. So first of all, what we have to do, we have to check whether the normal precipitation of D is varying greater than 10% with respect to this or this or this, any of one of them or not. So to do so, we need to see which is having the greater difference or the largest difference from 92.01. And as because all the values are lesser than 92.01, it is easy. But if the value is greater than 92.01, in that case we need to see what is a which is having the maximum difference or largest difference. Right here, 87.59 is having the largest difference between from this 92.01. Right. So you have to find out the difference, that is 92.01 minus 67.59, and you have to find out that what is the percentage of difference, right? So we are finding out the difference first of all, as because the maximum difference is this one. We're finding out the difference, finding out the percentage of difference, and this is 26.54. That means the difference of that station B means probably station B, it is having 26.54 5.4% difference from the normal annual precipitation. So obviously we need to go for the second equation, that is normal ratio equation. Equation is easier. Equation is easy, right? That is PD, precipitation at D at this particular year, will be equals to ND by 3, as because a minus 1 is 3 here as well. PA by NA, PA by PB by NB, PC by NC, and summation of those. All the values are known. Put all the values, you can find out what is the missing data of that. Right. Secondly, we can find out, or we have to check for the consistency. Consistency means whether the amount of precipitation should be there in a particular station was there in that particular station or not in the previous years. And to do so, and that consistency may break for various reasons, right? So again I'm saying consistency may break for various reasons. So when it will break, maybe suppose you are shifting in a station. So suppose from 1988 to 2020, one station was situated at a particular point, and after 2020 it is shifted to a new place, and 2024 it is running, right? So it may happen that due to the shifting of that particular station, it is recording a different data. So it will give you a false consistency or different consistency. We should not say false consistency, different consistency, as because it is providing you, suppose on an average 11 centimeter of rainfall. Now it is providing you on an average 15 centimeter of rainfall. So consistency can break because of that. Neighborhood of the station undergone a marked change. So we have already seen in the case where we are trying to find out what are the conditions are there while you install some sort of rain gauge station, where we have seen that the neighborhood or the nature of the neighborhood is pretty much dominant to the recording of the data. So if that neighborhood is undergone to a marked change, obviously there can be change after a certain time. Change in the ecosystem, and that is obviously a point, as because ecosystem is changing, so consistency may break. Observational error can be there. Suppose maybe one person was observing up to 2020, and after 2020 another person is observing, and they have two different type of observation. Obvious consistency will break from 2020. So to correct the consistency, we need to draw a curve that is called double mass curve. So it's a graphical method. Double mass curve. How to find out double mass curve? Now this method is based on the principle that when each recorded data comes from the same population, they should be consistent. So first of all, we need to see, or we need to first of all choose that station which will be under consideration. Nextly, at least we need to get 5 to 10 neighboring stations of X neighboring station. I've already told you that if you this is your X station, those will be the neighboring station. So at least 5 to 10 neighboring station we should consider from where we will collect the data. Now annual or monthly rainfall data from that X as well as the neighboring station are collected for 30 years maybe. Then what? Then average rainfall values of those neighboring stations are calculated. Now what is average rainfall value? I have already told you what is average. That is P1, P plus P2 plus P3 up to suppose Pn, n number of station, n number of neighboring stations suppose you are choosing, so divided by n. So if you are choosing 7 number of neighboring stations, so P1, P2 up to P7 divided by 7, that will be the average rainfall, and that will be considered as PAV suppose. Next, we need to write PAV value and PX values in two different columns, but in reverse chronological order. Reverse chronological order means the recent values will be at the top. That means suppose the 2024, 2023, 2000, though 2024 is running, I'm writing this 2022 and so on, right? So you have to make a order like this. You have to prepare two columns, that is PX column. I'm leaving the column blank as because we have to write something over there as well. So PAV in another column, and this is also blank. Why it is blank? As because we need to find out summation of PX and summation of PAV as well. Now what is summation of PX and summation of PAV? It is a cumulative value. Suppose here is 11 in 2024, PX is 11, in 2023 it is so 15, here it is 2 or something else, right? So cumulative values, how we can find out cumulative values, summation of PX for 2024, the value will be 11. In 2023 this value will be 11 plus 15, right? It's 26. Then in 2022 this will be 26 plus 2, 28, and so on. Similarly, for summation of PAV we need to do the same thing, right? We need to do the same thing, and so on. So we need to plot in reverse chronological order. Then we need to find out summation of PX and summation of PAV cumulative values. Next, in a graph we need to plot that summation of PX with respect to summation of PAV. Summation of PX will be in y direction, that is y axis, that is ordinate. Summation of PAV will be x axis, on the x axis, that is abscissa, right? And years will be marked on those points. Now the curve obtaining joining the points is called the double mass curve. Now you have to check for any break in the slope or not. So if you are having consistent slope, one slope is there, one slope, particular slope is there, then it is consistent. But if there is a change in the slope, your recording is not consistent, then you have to change or correct the consistent past records. You have to correct. This is one example where you can see 1970, this is 1970, 1969, 1968 and so on. In reverse chronological order we are providing summation of PX in y direction, summation PAV in the x direction, and we are getting those points. So those are the actual datas, right? So here it is clearly visible, but in the actual in the field data this will not be visible so clearly, right? So you can say one break here, one slope was there up to 63, up to after this 63 we are having a different slope. Now suppose this is the continuation or elongated portion of the slope. Now this is the slope basically of the year to say from 1970 to 1963. So we have to shift those values in this slope. How we can do that? To do so, we need to find out one ratio that is called correction ratio, and that will be equals to the slope of the corrected slope and the actual slope. What is the actual slope? This is the actual slope and this is the corrected slope. Now as because from this point to anywhere, from this point to this point or this point to this point to anywhere, if you are shifting this point to this point, you can see the base is common. This is the base for consider this. We are shifting this point to this point. Now this is the slope. What is slope? Slope is nothing but height divided by base. Here height is this one, here base is this one. You are shifting to this point where height is this one, base is this one. Now base is common, right? The ratio of between slopes will be nothing but the ratio between the heights. So we need to see the ratio, seeing in a particular point in a particular vertical line what is the height of the corrected slope, that is C, and what is the height of the actual slope, that is A. Now if you find out C by A, that is the correction factor. Now after finding out the correction factor, this correction factor will be multiplied to those datas the earlier datas, right? So that it will be shifted. So if you multiply this value with a factor C by A, automatically this height will be lesser and this value will be up to this, right? Again if this value is multiplied by a factor C by A, this will be nothing but this. So automatically all the points will shift to the new slope, right? We're having one example, and obviously this sort of example is large in terms of data. Those are not tricky, but those are large. You have to handle many data. So here you can see this is the example, the check for the consistency. One station is there, M, and the data for 30 years from 1950 to 1979 is given for M, and on the average value is directly given of the neighboring stations, right? So first of all, what we have to do, we have to find out sigma summation of PM and summation of P average, right? So we have to go for this table where up to this we have to do now, up to this up to this we have to do now to plot the graph, otherwise we cannot find the factor. Now we have to plot in this table in reverse chronological order. So reverse chronological order means 1979 will be at the top, 1978, 1977, and so on. So you have to likewise provide the data PM, this is provided data. You have to just arrange it in reverse chronological order. Next we have to arrange PAV, this is also given in reverse chronological order. Then we have to find out the summation of PM and summation of PAV, that is cumulative value, and I have told you how to find out that. So for 79 this will be 612, for 78 this will be 612 plus 426, so 1038. Again for the next year 1038 plus 825, that's 863, and so on. Here as well you need to find out in the similar way. You need to find out in the similar way. So after getting these values and these values, now you can plot the graph in this summation of PM and summation of P average with respect to reverse chronological order. Now here you can see that from 68 the slope is changing. If you extend the slope is in this direction, but if you connect the point of the actual data, it is in this direction. So we are having a change in slope. So a consistency break after 1968 is there, or from 68 is there. So what we have to do, we have to find out the correction factor, and to do so we need to find out one base. We have to select one point, any vertical line you have to draw, anywhere you can draw. You have to find out this depth, and this depth will be nothing but C, and this depth is nothing but A. Now in the last case the actual slope was the higher side of the corrected one. Here the actual slope is lower side, the corrected one. So if you find out C by A, here C by A will be greater than 1, as C value is higher. So if you multiply, it will be shifted upward instead of downward, it will be shifted upward, right? So you need to find out C and A. Either you can find out C and A, and otherwise you can find out MC and MA. So MC by MA, or whatever you can do, C by A you can do. Here you can see C by A, the correction factor is greater than 1, right? Now what you have to do, you have to correct the values. How you can correct the values? I have already told you, from 1968 onward there should be some sort of correction. So what you should, the correction value was 1 point something, correction factor was 1.173, right? 1.173. So you have to multiply 1.173 with each and every and so on, with each and every values. Multiplying this, you will get a corrected value. Those are the corrected value, adjusted value. Not corrected, actually adjusted, obviously. Now finalized value. Finally, in finalized value, up to this point, up to this will be same. This value will be same. After that, this value we need to write, and they have made it integer value. They haven't used any decimal. So this will be the data, corrected data. Okay, thank you. This is about the data presentation of how we can find out the corrected value, missing data. Thank you.